We are moving toward a network where autonomous AI models discover, negotiate, and execute complex workflows directly with each other, bypassing human prompts. In the baseline application economy on the left, you, the human, act as the router, paying strictly for raw compute consumed. But in the agent economy on the right, specialized models dynamically prompt other models to complete subtasks. The human is entirely removed. This creates an immediate structural problem. You cannot operate a functional machine-to-machine economy using input-based pricing, like paying for raw API calls. If one machine hires another to complete a task, it doesn't care about compute burned. It only cares if the task was completed successfully. A true multi-agent ecosystem requires outcome-based economics, where payment is released exclusively upon verified success. To transition to outcome-based economics, we must build an entirely new macro infrastructure stack, represented here in 4 distinct vertical layers. That stack consists of foundational orchestration, standardized network routing, verifiable execution, and autonomous settlement rails. The enterprises that successfully construct these specific layers will solve the core bottleneck, allowing one AI to autonomously hire, verify, and pay another. As we map this stack, the foundation begins at the orchestration layer, using frameworks like LangGraph or CrewAI. This is where specialized agents are built and exist as isolated computational entities. But for a raw script to become an active economic actor, it requires 2 specific primitives. First, stateful memory, to maintain persistent identity and historical context. Second, tool integrations, a secure API layer for taking actions in external environments. Currently, these highly capable agents operate inside isolated framework silos. An agent built in one system has no native way to communicate with an agent built in a competing system. Overcoming this requires the second layer of the stack, a unified routing protocol. Think of this as the TCP/IP or DNS layer for AI. This protocol defines a universal standard for how an artificial intelligence describes its specific capabilities, latency, and cost to the rest of the network. By standardizing these capability descriptions, agents can query the network and dynamically discover the exact services they need in milliseconds. Without this standardized routing layer, specialized agents remain entirely blind to each other, making a decentralized marketplace mathematically impossible. Now that our network is connected, consider what happens when an agent receives a complex multi-step objective from an end user. This decision tree maps the core economic computation every agent must immediately run, the build versus delegate decision. It first evaluates the execute locally path. This means relying entirely on its own parameter limits, compute resources, and context window to process the objective. Then it evaluates the outsource path. To do this, it calculates 4 variables: the network cost to hire an external agent, the latency of the transaction, the confidence or risk profile of the task, and the external agent's verified quality history. Using the routing layer, the agent identifies a highly specialized external node that can execute a specific subtask cheaper or with higher accuracy than it could achieve locally. This real-time meta-decision engine forces hyper-specialization across the network, driving down compute costs and creating the exact efficiencies of human free market economics. Delegation introduces an immediate vulnerability. Our delegating agent cannot blindly trust the unverified output of a third-party node. This brings us to the third layer of the stack, verifiable performance and evaluation. To guarantee the work was done properly, the hired agent executes its code inside an auditable, sandboxed cloud environment. This secure runtime acts as a definitive proof of work for the task. The resulting output is extracted from the sandbox and pushed through an automated evaluation platform, measured against objective success criteria. This evaluation layer strips away ambiguity. It functions as an automated credit rating system, yielding a definitive pass or fail. Once that output is verified as a pass, the executing agent has fulfilled its contract and must be compensated. That action triggers the top layer of the stack, agent-native financial rails. Traditional financial rails carry high friction and slow settlement times. They cannot support high-frequency, fraction-of-a-cent microtransactions between machines. Instead, these native infrastructure rails provide autonomous nodes with their own digital wallets, allowing them to settle metered transactions instantly and complete the economic loop. Verifiable execution, paired with instant autonomous settlement, provides the technical enforcement required to make outcome-based contracts actually function at scale. Right now, highly capitalized startups are building each of these stack layers in isolation, but this macroeconomy cannot hit enterprise scale until three critical gaps are bridged. Returning to our completed architectural stack, we can see it remains structurally incomplete. The first major gap is the absence of portable reputation passports. There is currently no standardized persistent performance score that tracks an agent's success rate and follows it from one deployment framework to another. The second gap is agent-to-agent dispute resolution. If an executing agent fails a subtask but still demands payment from the escrow wallet, there is no standardized arbitration layer or service-level agreement enforcement mechanism to resolve the legal void. The third gap is the lack of cross-agent audit trails. Regulated industries like finance and healthcare will block the deployment of agent economies until tamper-proof, human-readable records exist for every machine-led decision. The agent economy today is a collection of brilliant, fragmented pieces waiting for unification. The enterprise that successfully integrates standardized routing, objective trust verification, and frictionless settlement into a single coherent platform will own the fundamental infrastructure layer of the next digital decade.